Hello, this video is for IXL, Activity A1.B.4. It is titled Add and Subtract Rational Numbers, and the 3-character code for this activity is Juliet 8 Romeo. So rational numbers. So we're talking about numbers like fractions, like what you see here on the screen. It could also be decimal numbers. We'll be working with some mixed numbers. And we're going to use some strategies, like maybe finding like denominators and creating like fractions. We might be converting decimals over to fractions, or we might take fractions, like maybe the fractional part of a mixed number, change it over to a decimal, make it a little bit easier to work with. We'll use quite a few strategies in this video. So let's go ahead and take a look at our first problem. So the first one is 9/10 minus 1/2. So right now the denominators are not alike. These are unlike fractions because they have different denominators. That is the number at the bottom. So probably the best way to do this particular problem would be to find a like denominator between 10 and 2. So we're looking for the least common multiple. And by that we're saying if we count by 10, what numbers would we hit? And if we counted by 2, what numbers could we hit? Well, we can get to 10 counting by 10, and we can get to 2 counting by 10. We can get to 10 count by 2. There you go. So what I'm trying to say is we want to go ahead and make our denominator 10 in this case. Well, it's already 10 for 9/10, so we'll just leave that alone. So if we want to make 1/2 with a denominator of 10, well, making like fractions, let's go 1/2. We want to know what is a fraction that has a denominator of 10 that is equal to 1/2. Well, 2 is being multiplied times 5. So we're going to do the same to the numerator and multiply it times 5 as well and end up with 5/10. So we'll go ahead and put 5/10 there. Now, whenever we add and subtract fractions, or that is to say like fractions, having the same denominator, we just leave the denominator the same and we're going to subtract the numerator. So 9 minus 5 is going to be 4. Now, we could divide 4 and 10 both by 2 and simplify this to 2/5. So let's go ahead and do that. And our final answer is going to be 2/5. On the next problem, I have negative 1/10 minus negative 9/10. So let's go ahead and rewrite this over here. Let's start off with negative 1 over 10. And we're going to subtract from that negative 9 over 10. And let's go ahead and do a strategy that we've done before. Let's keep the first one the same, negative 1 over 10. Let's change the subtraction to addition. We've done this in a previous activity, right? Then take the opposite of the number that follows the sign that we changed. So subtraction to addition, negative 9/10 becomes a positive 9/10. We do have like denominators, so we're just going to leave the denominator as 10. Negative 1 plus 9 would give us a positive 8, right? It's a negative and a positive number. We have to add them together, so we're actually going to subtract. 9 minus 1 is 8, and since the 9 has the greater absolute value and it's positive, our answer is going to be positive as well. Now 8 and 10 are both divisible by 2, so 8 divided by 2 is 4, and 10 divided by 2 is 5. The next one is a decimal problem. So we have negative 8.5 plus negative 1. So let's go ahead and do that. Let's do, actually, let's think of it this way. They're both negative, right? And we're adding them together. So what do we learn? If we add two negatives together, then the answer is going to be negative. And since they are the same sign, we'll just simply add them together. So 8.5 plus 1 is going to be 9.5. So our answer is going to be negative 9.5. Next, we're asked to add negative 2 plus negative 8 and 9/10. Well, there's a couple ways we could do this. We could go ahead and create a mixed number out of this. So let's try that way first. So if we're going to create a mixed number out of it, we need to make a fraction out of the negative 2. So let's do that as 2 over 1, right? I can make a fraction out of an integer like negative 2 by just placing it over 1. Now we'll put plus, and let's do 10 times negative 8 is negative 80. Actually, it's been a little while. Think of this as a negative here, and now we're just going to take 10 times 8 is 80 plus 9 is going to be 89. and that's going to be over 10. Yeah, just about went 10 times negative 8 is negative 80 plus 9, and that wouldn't work because negative 80 plus 9 would give you a negative 71, right? So don't want to do that. So just act like the negative sign is not there. Convert the mixed number to an improper fraction, and then put the sign back on it. Now, in this case, we want to go ahead and have like denominators of 10. So let's go ahead and put this here, 10. The second one's going to stay the same. So we're going to stay with negative 89. There actually is an easier way to do this, and we'll look at that in a moment. So if I multiply 1 times 10 to get 10, then I need to multiply 2 times 10 to get 10. So I'm going to end up with 20, and that would still be negative. Now, I have like denominators, so I'm going to leave this as 10. Negative 20 plus negative 89. Well, I'm adding two negative numbers, so it's going to get more negative. And since they are the same sign, we're going to add them together. That ends up being, what, 109? Now, we could convert this back to a mixed number. It is going to be a negative number. 10 will go into 109 10 times with a remainder of 9, and our denominator is 10. So we could go with negative 10 and 9 tenths. Now, there is another way to do this. And also, real quick, negative 10 and 9 tenths, think of that as a decimal. Negative 10.9. 9 tenths. The 9's in the tenths place. So keep that in mind. And let's see if we come up with the same answer doing it another way that I think would actually be a little bit easier. This is negative 2, right? And we're adding to it a negative and 8 and 9 tenths. Look at this, 8.9. That's 8 and 9 tenths, right? Negative 8 and 9 tenths. That's what I have here. Only I've made it into a decimal instead. So now I'm adding two negative numbers together, so the answer is going to be negative. They're both negative, so we add the numbers together. 8.9 plus 2 is going to be 10.9. A lot easier this way, correct? Whole lot easier than the mixed number and creating like fractions by creating common denominators, etc. Just convert it over to a decimal and deal with it that way. On the next one, we have negative 1/2. We're going to subtract from it 2/5. And actually, let's go ahead and change that to addition. And then let's take the opposite of positive 2/5 as negative 2/5. Next, we want a common denominator, right? So, least common multiple, 2 and 5. If I count by 2s and I count by 5s, first number I'm going to come to is going to be 10. So we're going to give both of them a denominator of 10. Now, I had to multiply 2 times 5 to get to 10, so I'm going to multiply negative 1 times 5 to get negative 5. I had to multiply 5 times 2 to get to 10, so negative 2 times 2 is going to be negative 2 times 2 is going to be negative 4. Now I can go ahead and add straight across. Denominator is going to remain as 10. Numerator, I'm adding two negative numbers. It's going to get more negative. 5 plus 4 is 9. Negative 9 over 10 is my final answer. Next question, we have two decimal numbers. So let's go ahead and see how to handle those. Well, the first thing I notice is that I have a minus and negative. So I think I want to change this. Let's go at negative 4.75. Let's change the subtraction to addition. Let's take the opposite of the number that follows the sign that we changed. The opposite of negative 1.5 is positive 1.5. So now we are adding together a negative number and a positive number. So we know that that means we need to actually subtract them, correct? So let's go ahead and do 4.75. We're going to subtract from that 1.5. When we subtract decimals, we need to line up the decimals, right? So 5 minus 0 is 5. 7 minus 5 is 2. Bring down the decimal. 4 minus 1 is 3. So I end up with 3.25. Now, the one with the greatest absolute value is the sign we're going to use. So negative 4.75 has a greater absolute value than 1.5. So since negative 4.75 is negative, my answer is going to be negative. And the next one, let's go ahead and go negative 7.95. minus, but let's change that over to addition instead. Let's take the opposite of the number that follows it. In this case, it is negative 2.5, so we're going to make it a positive 2.5. Now, just like the last problem, we are adding a negative number and a positive number, so that means we're actually going to subtract. So let's go 7.95. We're going to subtract from it 2.5. Again, keep those decimals lined up. 5 minus 0 is 5. 9 minus 5 is 4. Keep your decimal lined up. 7 minus 2 is 5. My answer is 5.45. And should we use positive or negative? Well, the negative 7.95 has a greater absolute value and it's negative, so we're going to use the negative sign. Here we have two mixed numbers. Now, if we think of it this way, if I add the negative 4, I could take a shortcut here. I could, well, first, many people would say, okay, convert them over to improper fractions, create like denominators, etc. So let's go ahead and try that. The first one's negative. It's going to have a negative numerator. 5 times 4 is 20, plus 2 is 22. And the denominator is 5. We're going to add to that 4 times 4 is 16, plus 3 more is 19, and our denominator is 4. It's going to be a little bit of work, right? Now, least common multiple of 5 and 4 is going to be 20. So 20 and 20. I multiplied 5 times 4 to get to 20, so I need to multiply 22 times 4, which should be, what, 88? And remember, it's negative. Now, 19 was multiplied, or 4 was multiplied times 5, so 19 times 5 should be 95, I believe. So we can go ahead, add straight across. Our denominator is going to be 20. Now we have a negative that we're adding to a positive, so we actually need to subtract. And I really think this is a long way around, but just to show you here, we're going to subtract. So the difference between 95 and 88 is 7. From 88 to 90 is 2, and then from 90 to 95 is another 5. 5 plus 2, 7. The difference is 7. And should it be positive or negative? Well, 95 has a greater absolute value and it's positive, so we're going to leave that as positive, and we're going to call that 7 over 20. Now, another way we could have done this is, think about this. The negative 4 is going to be offset by the positive 4. So those would just cancel each other out, right? So let's see if this will work. Can we take 2/5 and add to it 3/4? Now, still our like denominator is going to be 20. And 5 times 4, to get 5 times 4 to 20, 2 times 4 is 8. And now we have, did I have a negative number there? No, the negative got canceled out over there. Oh, this isn't going to work because the 2/5 is actually negative also. Watch, I'll show you. It's not going to work. 15, and then I'd have 8 plus 15 is going to be 23. And then if we change that over to a mixed number, that would be 1 and 3 over 20. Nope, that doesn't work. The reason why is this. Here's where I made my mistake. This 2 is actually negative. That is negative 4 plus negative 2/5. So if I think of this as negative 2/5, now let's try it. Denominator 20. And I multiplied times 4, so this will be negative 8. And 4 times 5, that'd be 15. We have to add them together. The difference between 8 and 15 is indeed 7, right? And the 15 is greater absolute value. So in this case, it would be positive as well. And so I end up at the same 7 over 20. It's been a little while. I've done that before in the past, is that I forget that negative 4 and 2/5 is the same as negative 4 plus negative 2/5. So whenever you do that, if you tried that strategy, you have to remember that the fraction is negative as well. It's not a positive 2/5. It's a negative 2/5 being added to negative 4 to get a negative 4 2/5. All right. On the next one, this one here, let's see, 7/8. Let's try dividing. I could do this with a calculator. I want to change 7/8 to a decimal. So 7, I want to divide it by 8. I think it comes out to 3 digits if I recall. 8 times 8 is 64. And the difference there is 6. And we throw the 6 there. And 7 is 56. And that's 4. We bring a 0 down, and that's 5. That's what I thought. So 7/8. Remember, every fraction is a division problem. So all I did was I just divided 7 by 8, right? So let's go ahead and take negative 1.4, and we're going to change this to addition, and take the opposite of positive 7/8, right? Because that's a positive 7/8. So this is a positive 8.75. So let's change that to a negative 0.875. Now, they're two negative numbers, so they're going to get more negative. So I need to actually add them together because they're the same sign. So I could do 1.4. Going to add to that 0.875. Throw a couple zeros there for placeholders. I get 5, 7, 8 plus 4 is 12. Carry the 1, 2. So, and it's supposed to be negative, right? So we'll throw a negative sign in front of that. So negative 2.275. We did that by changing the 7/8 to a decimal, by dividing the numerator by the denominator to get the decimal equivalent. Chances are most people would just use a calculator than doing the long division. Final two questions. Let's see, 5.5. That's a decimal, and I could change negative 9 1/5 over to a mixed number, but I happen to know that 1/5 is equal to 0.2. So let's do this. Let's go with 5.5 minus, let's take the opposite of negative 9 1/5 and make it a positive 9. Instead of 1/5, we're going to put 0.2. If you divide 1 by 5, you will see that that equals 0.2. So 5.5 is positive, changed it to addition, silly me, and then took the opposite. So they're both positive, so I just need to add them together. So I'm going to take 9.2, add that to 5.5, and leave the decimal lined up. That's 7, that's 14, so 14.7. And it indeed should be positive. I'm adding two positive numbers together, so the result's going to be positive. And I'm going to use the same strategy on the last one here. I know that 1/2 is equal to 0.5, so let's go ahead and do this. Negative 2.2, negative 2.2. Let's change the subtraction to addition. Let's take the opposite of the number that follows it. So this is a negative 1.5 or negative 1.5. We're going to make it a positive 1.5. Now I'm adding together a negative number and a positive number. So that means I'm actually going to subtract. So I'm going to take 2.2 and subtract from that 1.5. Keep my decimal lined up. I'm going to need to borrow from the 2, make that a 1. This becomes a 12. And 12 minus 5 is 7. And 1 minus 1 is 0. So I end up with 0.7. Is it positive or negative? Well, the negative 2.2 has a greater absolute value than the positive 1.5. So let's use the negative sign from the one with the greater absolute value. And the answer is going to be negative 0.7. All right, so that concludes all of my examples for IXL A1.B.4 Add and subtract rational numbers. Good luck with your activity.